So let's see, find a safe walk through a grid. So the problem is you've got a matrix m times n. M and n are quite small. Yeah, you've got integer health, and you start on the upper left corner, and you want to go to the lower right corner without, your health reaching 0. And you've got some cells that are unsafe, and some cells are fine. You lose 1 health when you go on a safe cell, and you don't lose any health when the cell is 0. So here you can go to the bottom like this. Here you can't go to the bottom. Let's say you go that way, you lose 2 health, you only have 1 left. Sorry, and then you lose another 1, and at this point your health is 0, so you can't really move anymore. And the final one you can, because you lose 1, 2, 3, 4, so your health is 1 at the end, and that's fine. So the idea is you want to traverse the graph. The only problem is if you traverse the graph, give me a sec. Yeah, if you traverse the graph with the DFS, let's say you're here, you can go right, you can go down, but then when you're here, you don't want to come back to the left, right? Otherwise, it's going to be an infinite loop. The problem is you can't just have a visited set. Typically, we just have a set visited with all the x, y's we've seen so far. The only problem is if you go that way, -1, -2, -3, you get there with 1 health, right? And you conclude, okay, here this cell is impossible, right? But then you go that way, and then you arrive here, and you can't say, oh, I've visited this cell already. I'm not gonna continue, because if you did continue, you would have arrived to the end with positive health, right? So the problem is you can't just say, I've visited the cell, I don't want to visit it again. But you can say, if I visited the cell with a certain amount of health, then fine. If I arrive at the same cell with the same amount of health, then I don't want to visit it again, right? If you arrive at the same cell but with 10 health instead of 5 health, then you want to continue, because maybe now you have a chance of getting out of the maze. It's not really a maze, but you get the point. So let's do the code. I've got some test cases here. So the first thing to do is, first maybe let's explain why it works. So it works because m and n are small, and the health is going to be small as well. 50 to the cube to the power of 3 is fine, so we won't have any issues here. So it creates a set visited with 2 integers and a boolean. So that's going to be x, y, and health, and we just do just standard DFS, right? So x, y, health returns a boolean. The first thing we'll do when we arrive on a new cell is if we can just say health minus grade xy, right? Xy minus equal. So what does that mean? I'm going to disable this. What does that mean? That means if the grade is 0, you don't lose any health. If the grade is 1, you lose 1 health. And at the end, you just return DFS 0, 0, and the health you have. Right. So you lose your health, then you want to check if you've arrived by your destinations, right? So if x equals len of grade and y is equal to len of grade 0, and you still have some health back, then you want to return true. Otherwise, it means you're not at the end, and you want to see if you can get to the end. First of all, if health equals 0, well, I would say is inferior or equal to 0, then you return false. You can actually put that here. We actually should, check the health first, and then after this point, we know our health is bigger than 1 at this point. And then we want to check the neighbors if we aren't at the end of the grid. Not end, the bottom right part of the grid. So to check our neighbors, we iterate so the 4 directions. It's 4 directions. It's going to be 1 0, minus 1 0, 0 1, 0 minus 1. So that's well, maybe dx is not the right term, but that's going down, that's going up, that's going right, and that's going left, right? Maybe naming those variables that way is not ideal, but you get the point. Then the first thing you've got to do is make sure x plus dx is between 0 and len of the grid, otherwise you'll have out of bound exception, and 0 y plus dy grid 0, right? You've got to make sure we are in bounds. Next thing is if x plus dx, y plus dy, and health are invisited, just continue, right? You've been there already with the same amount of health, and you know the conclusion already, so no need to do anything. But if it's not invisited, then first we add it to visited. So we add this very tuple to our set, and then we call our function. So what is it complaining? I don't know why I said boolean. Yeah, that's an integer, sorry. Then we call our function, right? And then we return. I just realized the mistake. Yeah, you don't want to return straight away, right? Because if you go down, right, and you don't get to the end, so your call is going to return false, right? You can't say false straight away because you haven't tried to go left, you haven't tried to go, that's not left, sorry. You haven't tried to go up, you haven't tried to go right, and you haven't tried to go left. So you only return true if your recursive call returns true. Otherwise, you have to wait to have tried all directions before returning false. Alright, and actually this also as well, that's my bad. The end of the grid is obviously the length minus 1. Should be fine now. Okay, so now all the test cases passed, at least all custom test cases, and we can submit. Up, and then we can try and submit. And so that's accepted.